Dear students, in this lecture we will see the method of undetermined coefficients in ordinary differential equations. This presentation is based on the book Mathematics 2 for B Semester 2 by Dr. Shailesh S. Patel Atul Prakasam. So friends, in the previous two lectures we have seen the method of finding the solution of ordinary differential equations which are linear and with constant coefficients by finding complementary function and particular integral. Then summing these two in the form of yc plus yp, we were obtaining the general solution. But here we will see another method of finding the general solution of linear ordinary differential equations, which is known as undetermined coefficients. Here the procedure of finding complementary method is exactly same as we have seen in the previous lecture. But ypx we can find by using undetermined coefficient. So mostly one question appears in the examination by asking the question in the form of find the solution of the given differential equation by using undetermined coefficients method. So you must have to apply this method. You cannot use that the method of yc plus yp particular integral which we have seen. So here we will see the process of finding undetermined coefficient method. So this we will discuss directly by considering one example, because it is very easy. Here the same kind of equation which we will be given as we have seen in the previous lecture series. So here you can see that we are given the equation y double dash plus y dash minus 12y equal to e raised to 3x. The same equation we can also solve by using the previous methods, but here we are asked to solve this by using method of undetermined coefficients. So first of all, we will identify from this equation f of x, small f of x. Actually the initially whatever we have written as L into bracket y, that means L is nothing but it is similar kind of operation which we were writing in the previous equations in the form of b square plus b minus 12 bracket over y. Here L means the linear, uh, it is linear with constant coefficients, the same. So if you don't write this, then also it will do. But first identify small fx. Here we will write, we were writing this as capital Rx, but now and onwards we will write down this as fx. So fx equal to e raised to 3x. Then the first way is to finding the generated sequence of f of x, that means right hand side. And it is very simple to obtain generated sequence. First, if you learn this process step by step, then all the examples you can find in the similar way, because it is very simple. No further integration is required. Simply you require the simplification process. So here the generated sequence of fx is fx equal to e raised to 3x. That means arrow here we have used because it is not exactly equal to. We first write down the same function which is given e raised to 3x, then find out its derivative and go. If we are getting different functions, then we can continue the process. But if we are getting same kind of functions, because we are interested in special kind of functions, different kinds of functions. So here in every derivatives we can see the same function appears, e raised to 3x. So we will stop here and write on dot. So we will identify from this different special functions which appears in this generated sequence. So the finite family for fx is fx equal to e raised to 3x times to e raised to 3x. So only one function we have obtained here. No other function is there. Constant multiplication coefficients we avoid them. So after generating this family, now we can write down ypx directly as capital A into e raised to 3x, where capital A is some constant. Capital A is some constant, and this we want to determine, as our name of the method is method of undetermined coefficient. So this is the coefficient we have added, and it is undetermined, and that we want to determine. So once if you determine the value of a, the process of finding the solution, that means ypx, is over. So after writing ypx in this form, just put the pause over here and find out homogeneous solution of homogeneous part of the given equation. And it is very simply, we know, you can do in the same paper, or you can do on the rough paper also and write down the final solution. Here you can find this by using m square plus m minus 12 equal to 0. Factorize this polynomial, you will get the two different factors, 3 and minus 4, and hence ycx you can write as c1 e raised to 3x plus c2 e raised to minus 4x. Now just see ypx, refer ycx and ypx. In ypx we have used e raised to 3x. So this e raised to 3x should not be exactly in common form in ycx. If it is not appearing in the common form in ycx, then we will continue the process by considering as the same given function. But if it is duplicating, then we need to consider ypx in some other form. So here you can see that e raised to 3x is duplicating with ycx. So we will revise ypx as ypx equal to a into x. That is the process is very simple. Multiply this by x. So a into x into e raised to 3x. Now again check whether x into e raised to 3x is duplicating. But you can see x into e raised to 3x is not there in ycx. You can see easily. So there is no duplication now. So this is our final ypx. Now to determine capital A, that is constant, we substitute this value in the given equation. Given equation is y double dash plus y dash minus 12y equal to 0. That means find out its double derivative first. So double derivative is this one. Then y dash is here, these two, and then plus minus 12y. 12y is y has the value ax e raised to 3x, and equal to e raised to 3x, which is given to us. Then simplify here. You can see e raised to 3x will be common from all of the terms, and this will be cancelled by on the right hand side and left hand side. So if you summing up all other terms, then you can get 7a equal to 1, and hence a equal to 1 by 7. So ypx equal 1 by 7 x e raised to 3x. And therefore the general solution is yx equal to ycx plus ypx, and you can see this is what the solution is written. So here you might have observed here that no integration or no any more other application of any other formula is required here. Simply we require to find out the constants. Let us see another example. Here you can see y double dash plus 4y equal to 8x1. So given equation in the form of linear, that means L of y equal to fx, and fx equal to 8x square. Now we find out its generated quantity. The process is very common. First find out generated quantity. So fx equal to 8x square tends to 8x square, then its derivative, you can see that it is going on 0, 0, 0. Then from this find out, we will take different special functions. So f of x equal to 8x square tends to, here you can see that from this we can take x square, from this we can take x, and from this we can take 1. 16 we cannot consider because 16 has the coefficient 1. So 1, x and x square. 0 we cannot consider because 0 and 1 are coming in constant forms. So constant term is 1, x and x square. That means we have obtained three different functions in this family. So we write down tentatively ypx as ax square plus bx plus c, into 1. So this is our ypx, and capital A, B, C are the constants. These are undetermined, and we want to determine their values. And this is our process, and this is this is our method. So now we will find out homogeneous solution. Homogeneous solution is obtained very easily. The auxiliary equation is m square plus 4 equal to 0. So m equal to plus or minus 2i. So complex roots are there. So ycx equal to c1 cos 2x plus c2 sin 2x. Now we will verify whether there is duplication with the terms of yp and with the terms of yc. In yp we can see that there are three terms, x square, x and 1. And in ycx there are two terms, cos 2x and sin 2x. So we can see obviously there is no duplication. No duplication, so we will keep ypx as it is, that is which is written in equation number 1. Now we put ypx in the given equation, that means y double dash plus 4y. So y double dash means here we require to find out double derivative of ypx, and then here we will put value of y, that is directly as it is, and equal to 8x, where you can see here 2a plus 4ax square plus bx plus c equal to 8x square. Then we will equate the coefficients of like terms. Like terms, that means on both sides the coefficients of x square, coefficient of x. Here we can see that coefficient of x square is 4a, and on right hand side it is 8, so 4a equal to 8. On left hand side the coefficient of x is 4b, and on right hand side it is 0 because no term containing x is there. So by using this we can find out the values of a, b and c, and by substituting these values in the assumed ypx we can find out the actual ypx. Then the general solution is yx equal ycx plus ypx, and we can see the solution. Let us consider another example. Here you can see the equation is second order. On right hand side we are given 6x plus 3x square minus 6x cubed. As usual, we continue the example with writing the given equation is in the form of L of y equal to fx, where fx equal to fx means right hand side 6x plus 3x square minus 6x cubed. Now we find out its sequence, generating sequence. So derivatives, that is. So first we will write down this given fx as it is, then comma its derivative 6 plus 6x minus 18x square, comma 6 minus 36, comma minus 36, comma 0, comma 0. So from each of these functional forms we can see that there are the different functions are x cube, x square, x, and the constant. Constant is due to minus 36 or due to 6. Okay. So we will write down ypx very easily. Ypx you can write down here, it is written after some time, but you may also write down at the initial stage. Ypx equal to ax cube plus bx square plus cx plus d. That means a, b, c, d, 4 different constants that we want to determine. So meanwhile we will obtain ycx. So you can also write down ycx directly by doing proper work on the rough paper, or by showing in the same solution. M square plus n minus 6 equal to 0. It has the two roots, 2n minus 3. So ycx equal to c1 e raised to 2x plus c2 e raised to 2x. Now we can see that in yc there are two different terms, e raised to 2x and e raised to minus 3x. And in ypx there are the terms x cube, x square, x and 1. So we can see that there is no duplication in ycx and ypx. So we will keep ypx as it is, and we will substitute the value of ypx in the given equation by finding y double dash, y dash, and simply 1. As in this, if we substitute the value of ypx, we can get this equation, and then we can equate the coefficients of like terms, that is coefficients of x cube, coefficient of x square, coefficient of x, and constant on both sides. We can get these equations, and one by one if we solve these equations, then we can find out the values of a, b, c, d. Here we have obtained a equal to 1, b equal to 0, c equal to 0, d equal to 0. So ypx equal to x cube. Therefore the general solution is y equal to yc plus yp, and you can see the solution is arrived. Here is the example for your practice. Solve y double dash minus 2y dash, or we will see the process, whatever it is. Y double dash minus 2y dash plus y equal to x square e raised to x. As usual, write down given equation as Ly equal to f of x, where fx equal to x square e raised to x, that is right hand side. Then find out its family by finding the derivatives, x square e raised to x, 2x e raised to x, 2 e raised to x, and so on. Actually it has the derivative x square e raised to x means 2x e raised to x plus x square e raised to x, but we will get e raised to x has the same derivative, so we will get the same term. So I have not written this one because we want different kinds of function which is which are arising during the derivatives. So here we can see that the different kinds of functions which are arising are x square e raised to x e raised to x, and e raised to x. So these are the different three functions. Then no further different function will arise because derivatives of e raised to x will not become 0 at all. So we will have ypx, here it is written ypx equal to, you can see ax square e raised to x plus bx e raised to x plus c e raised to x. You can see in the equation 2 it is written. Then meanwhile we find out homogeneous solution, that is ycx complementary function y double dash minus 2y dash plus y, so m square minus 2m plus 1 equal to 0, so m minus 1 whole square equal to 0, so m equal to 1 1, so its solution is written as c1 plus c2x equals to 1. Now in ycx we can see that there are two different functions. C1 has the coefficient e raised to x, so e raised to x and e raised to x. Not that e raised to x and x e raised to x are two functions, and the ypx there are three functions: x square e raised to x, x e raised to x, and e raised to x. So we can see, is there any duplicating function? Yes, it is there, because e raised to x is also duplicating and x e raised to x is also duplicating. So if at least one function is duplicating, then we need to follow another process. That means we need to revise this ypx by multiplying this by x. But here there are two functions, are whatever one or two or three functions may be duplicating, but simply we require to multiply this by x. So if we multiply this by x, then we can get here x cube, here x square, and here x e raised to x. Then again we can verify. Again we need to verify with the functions of yc. That means e raised to x and x e raised to x. So again here we have obtained x e raised to x, so this is duplicating. So again we need to divide this and multiply this by x. That means x square. So x raised to 4 here, x raised to 4 term is not in yc, x cube is here, it is also not in yc, x square e raised to x is here, it is also not this. So this is our final. So we have written here ypx as this is into x square, and if we take x square inside and e raised to x common, you can see this is our ypx. This x square we have taken inside and e raised to x outside only due to the purpose of the derivative, because we want to substitute this value in the given equation to determine the values of capital A, B, and C. So this is the equation y double s minus 2y dash plus y equal to 0. So first, it is lengthy process because the functional form of yp is lengthy and the derivatives will become some tedious. So we have obtained yp dash, yp double dash separately and simplified them and then substituted in the given equation, and after then e raised to x will be cancelled on both sides, you can see, and then it is become simple because we need to compare the coefficients of x raised to 4, x cubed, x square, x, and constants. So we have obtained this kind of equations, and solving each of them we can get the different values. That means a equal to 1 by 12, c equal to 0, b equal to 0. Okay, so we have the final solution after substitution of the values of capital A, B, and C is ypx equal 1 by 2 x raised to 4 e raised to x. So the general solution is y equal yc plus yp. So you might have observed in this process that this process is very simple. No requirement of any integration or any other formula. Simply you require to simplify the right hand side function, that means to identify different kind of functions which are arising. Then from this you substitute ypx in the given equation. After verifying that there is no duplication with ycx and ypx. If it is duplicating, then multiply x, again check. If it is duplicating, again multiply by x, and continue the process. You will get the solution very simply by determining the constants capital A, capital B, capital C, whatever arising. Okay, thank you. Thanks to students for this lecture.